In this video, I'm going to take a look at bokeh, a word derived from Japanese for blur, the out-of-focus areas in photographs. It's an area of photography that generates a lot of heated discussion online, as I found out when I posted a video in 2020 suggesting that digital photography has elevated bokeh to an art form. People can have very different views about whether or not they like the look of the bokeh in any particular photo. Whether, for example, you think the bokeh is too busy, or too nervous, or too ugly. Or, on the other hand, you think it's too soft, blurring out potentially interesting details in the subject matter. Personally, I think good bokeh is bokeh that complements an overall image, and that it doesn't distract from the person or subject in focus. Indeed, it can help to give the in-focus parts an extra pop, and in the right compositions, a sense of 3D isolation. A technique that mobile phone photo algorithms, for instance, have in their portrait modes. In some compositions, the bokeh can be very beautiful, with a smooth, artistic, painterly look. But bokeh doesn't necessarily have to be smooth and subtle. Busy bokeh can actually add to the visual impact of an image in an interesting, sometimes beautiful way. No doubt that's why some people like lenses that produce busy, swirly effects. And busy bokeh in the foreground can also create an eye-catching image. At least that's my perspective. You may have a different view of the aesthetics, and it's clear that the perceived quality of bokeh is very much a matter of personal taste. Furthermore, some photographers complain about what they see as a ridiculous obsession with bokeh, arguing that good photography is much more about capturing a subject in focus, not the blur, and they have a point. There are many really good articles and debates online covering all sorts of issues to do with bokeh. So maybe there's little more or new to be said about the subject. However, I think there is more to be said. I think there are still some unanswered questions and misconceptions about bokeh. Discussions often miss some of the most critical things, and as a result are more subjective than they should be. In fact, I believe it is possible to analyse bokeh in a more scientific and objective way, and explain all the different factors that impact bokeh in one coherent approach. And in the process, this should help to shed more light not just on bokeh, but also the types of lenses most suited to capturing bokeh-rich images, and the skills and techniques for using those lenses. So that's what I'll be attempting to do in this video. My analysis begins with an age-old method of discovery, and that's observation, looking at scores of images from different lenses. Because after a while, you can learn how different lenses produce different styles of bokeh. And you can learn how these styles are linked to a lens's optical design, as the optical design has a strong impact on what the bokeh looks like. I'll start with quite a narrow definition of optical design, to mean the arrangement of glass in the lens, the number of glass elements, their curvature and groupings. During the video, it'll soon become apparent that this narrow definition of a lens's optical design is only part of the story. There are many other factors involved in explaining why bokeh looks the way it does. And indeed, not all these factors have to do with the lens itself. But that's for later. So if you take a cross-section of film-era lenses, it is broadly possible to tell what the bokeh will look like from each lens, based on its name and optical design. Let me show you, starting with the easy ones, not necessarily in the order these optical schemes were first introduced. The Bokeh design is a good place to start, famous for its swirly but reasonably smooth bokeh. This is an early Carl Zeiss Jena Bokeh, 58f2. As I'm sure you know, the USSR's Helios 40 and 44 series lenses adopted the Bokeh design and produced similar swirly bokeh. And there are other lenses that will produce swirly bokeh, sometimes known as the Petzval effect, after Joseph Petzval, who designed a portrait lens in 1840. Another easy pick in terms of distinctive bokeh are lenses with Cooke triplet optical designs, because these lenses produce very distinctive soap bubble bokeh. Triplets were very early designs, but the most famous lens today with the triplet design is probably the Meyer Optik Görlitz Trio plan. The soap bubble bokeh look is produced by obvious lines around the out-of-focus highlights. Other lenses don't produce such distinctive lines as this, as we'll see later. Alongside the Cooke triplet and Bokeh designs, a third, highly influential and early optical design is the Tessa. I've got some Tessa design lenses here, including the Carl Zeiss Jena Tessa 50 f2.8. Tessa design lenses have a reputation for their stop-down sharpness, but their bokeh wide open can be a little harsh, not the smoothest. But to be fair, testers were never optimized for wide open performance. If you like smooth bokeh, then you may prefer Sonor-design lenses. There are two conventional Sonor-design lenses on the table, and lovely lenses they are. The Carl Zeiss Jena Sonor 135 f3.5, and this rather unusual use of a Sonor design, a Takuma 58 f2 from 1957. These Sonor lenses produce smooth out-of-focus rendering in the right conditions. And the use of the design continues to this day, for example with the lens highly rated for its bokeh, the Sony Zeiss Sonor 55 f1.8. Now, less well known as a brand name, but highly influential as a lens design, is the double Gauss configuration, a design that dates back to 1888. There are a large number of popular lenses that have this design, made by Leica, Nikon, Canon, Pentax, Olympus, Fujinon, Minolta, Konica, Topcor, to name more than a few. There are a handful of these lenses on the table. Not everyone is totally enamored with the bokeh produced by these double Gauss-derived lenses. Some of the bokeh can be eye-catching, but also quite crazy sometimes. To pick images from just two lenses, a Minolta and a Nikon, you can see how strong the bokeh can be, wide open in the right conditions. A double Gauss type lens, a generally more controlled bokeh, is Leica's Summicron R 50 f2. Then there are planar branded lenses originating from Zeiss, such as this one, and it's also worth including this Ultron lens, also made for Zeiss, to a design by A.W. Tronier. Planars and Ultrons can be great performers overall, especially as portrait lenses, but opinion seems to be divided on the quality of their wide-open bokeh compared to the smoothest of lenses. There are some other, smoother derivatives of the Ultron design, including these Takuma 55 f1.8s. I personally prefer the bokeh from these ones. I'd like to mention one more manufacturer on the table, Tomioka-made lenses, whose bokeh can range from utterly beautiful to flared out in bright light. This Tomioka Auto Revuenon 55 f1.2, for instance, produces extraordinary tunnel-like bokeh wide open. Finally, there's a whole myriad of lenses not on the table, with different types of optical designs that produce beautiful or eccentric bokeh. For example, soft focus lenses, specifically designed to produce a soft look. Mirror lenses with their donut-shaped out-of-focus highlights. And modern lenses such as those made by LensBaby, a company that, in its own words, designs lenses for people who embrace weirdness and imperfection. Plus, there are modern lenses that allow you to change the bokeh, and how out-of-focus points appear in an image. There's a list of these types of lenses in Todd Vorenkamp's excellent article on understanding bokeh on the B&H website. Away from the more exotic modern lenses, lens designers of prime and zoom lenses, aided by computers, work hard to develop lenses that are sharp and at the same time produce bokeh at all f-stops that will appeal to their customers, or at least it won't be irritating on the eye. Modern lenses in general, there are a few exceptions, are much more complex than the old film-era lenses on my table, both optically and electronically, as you can see by comparing diagrams of modern lenses versus old lenses. One thing I've noticed recently is how the definition of bokeh in online sources is tending to gravitate towards a focus on distinct points of light in the out-of-focus areas. In particular, the so-called circles of confusion, out-of-focus highlights that appear as bokeh balls or bubbles or cat's eyes, and specular highlights and reflections, those bright spots of light that you see on shiny objects. As far as I'm concerned, bokeh is blur, and that covers the rendering of all out-of-focus areas, not just the highlights. However, I can see why the photographic industry needs to focus on distinct spots of light, because those highlights can be measured and included in tests of lenses at all f-stops before and after the lenses are mass-produced. It's much more difficult to measure and test blur without any highlights, so perhaps it's not surprising technical discussions of bokeh do tend to focus on highlight effects. Anyway, that's a brief description of how different brands and optical designs produce different kinds of bokeh. Big apologies if I've missed one or more of your favourite optical designs. There's one other optical design lens configuration I should mention, and that's where you reverse one or more of the elements in a lens. I've got examples of the kind of bokeh that reversing elements can produce from 3 lenses. It's quite wild. You can see twisted, swirly highlights, coma, and other distorted effects, but I like it. Now, as you can't fail to notice, I've already slipped into a more subjective analysis of the quality of bokeh, and after the more obvious Biotar, triplet tessa, and sonnet optical designs, I've started to voice my own opinions. And by focusing purely on optical designs and a selection of carefully chosen images, we're missing some of the key factors that impact what a lens's bokeh is going to look like in any given situation. What we need is a universal formula that explains why bokeh looks the way it does, covering all the key ingredients that influence bokeh. The right place to start building this formula is not with the lens, but with the camera. Most of the images and tests I'm going to show you in this video were taken with a full-frame digital camera. People ask me if the lenses I've reviewed with a full-frame camera will produce the same bokeh on their crop sensor cameras. My response is generally yes, they will. It's still the same lens, producing the same effects. The difference is that the edges of the frame are cropped compared to a full-frame sensor. Indeed, some of my favourite bokeh-rich photos have been taken with a crop sensor, including lenses that produce swirly effects, i.e. the crop is not severe enough to crop out all the swirls away from the centre of the image. Here's another shot taken on a full-frame camera with a wider angle lens that's not a swirly lens, but it produces a lot of bokeh. And here's the same scene, shot separately with the same lens, but this time using a 1.5 crop. You still have a lot of interesting bokeh in the frame, and if you want to have a wider frame, you can always take a few steps back. Having said this, the size and performance of the camera's film or digital sensor can make a difference to bokeh, and there's a lot of information online about the impact of different sensor sizes on bokeh if you're interested. In short, there's approximately a one-stop difference between micro four thirds and APS-C, and a further stop between APS-C and full frame, and a faster stop means a narrower depth of field, a more out-of-focus blur. And the more powerful the sensor, the more details it picks up, giving you more control over the detailed sharpness and smoothness of in and out of focus areas. Going back 100 years or more, you don't see so many bokeh-rich photographs, and one reason for this is the slower speed of plates and film, not just the slower lenses. At this point, you might think that the lens should be the next part of the bokeh equation, and of course the speed of the lens, the size of its aperture, its optical design and so on, is critical to understanding bokeh. However, I'd argue that to understand the look of bokeh, it's not the lens we need to consider next, it's the composition and light. By composition, I mean the scene being photographed, what's in focus, and what kind of shapes and objects are in the background and foreground. To keep it simple, I'll mostly refer to backgrounds from now on. In any composition, the light is critical. What are the sources of light? Where is the light coming from? Is it shining straight down the lens, or is it coming from the side and reflecting off objects? And what are the light and dark contrasts in the composition? The way bokeh looks is very strongly influenced by the composition and the type of light shining on or through the background. Even lenses that produce the smoothest bokeh can make the background blur look busy if the background is busy or the light is producing very strong contrasts. I mentioned that Sonnet lenses can produce smooth-looking bokeh, but not even Sonnet lenses can cope with complex, cluttered backgrounds. Conversely, optical designs that are notorious for busier bokeh, and I called out some Tessa lenses as an example, even Tessa lenses will produce very smooth bokeh if the background is uncluttered with objects or highlights. I know this all sounds like simple common sense, but it's surprising how composition and lighting differences are sometimes ignored when people talk about a lens's bokeh. Oh, this lens has such busy bokeh, you'll read, with a photo like this to demonstrate why. Well, it's going to be busy. The lens is photographing a busy high-contrast background. The choice of composition and light also makes a difference when you're trying to extract the kind of bokeh effects you're expecting to see given a lens's optical design. For instance, people who buy a Helios 44-2 lens sometimes comment they can't get the kinds of swirly effects they've seen other photographers produce, but that's often down to the choice of composition and the light available. I've taken plenty of photos with my Helios lenses that don't show swirls. Without the right composition and light effects, you're not going to see a lot of obvious swirls. And more generally, for swirly and non-swirly lenses, the way the out of focus areas are lit will have a significant impact on the bokeh. To give you an example of how light can change the look of an image, here's a small tree I've photographed with a variety of lenses at different times of the day and in different sunny and cloudy conditions. These 4 shots were all taken at the same time in the late afternoon. And then for comparison, these shots were taken in the early morning, with a low sun almost in front of the camera. Looking at these photos, I think it's fair to say that the light and reflections in the background are having a much bigger impact on the bokeh than the optical design of the lenses. Talking about light, you can see how the size and shape of the out-of-focus highlights differs across these images. And this is one of the most interesting ways of distinguishing the bokeh produced by different lenses. But before considering this, we need to talk about depth of field. Depth of field is closely related to a lens's optical design, because the faster the lens is, and the longer its focal length, the narrower its depth of field will be when you take closer-up shots. With a narrow depth of field, you're going to see more of out-of-focus areas, and if you're focusing closer up to an object, you're generally going to see smoother bokeh, subject to the composition and light, of course. Closer up is the operative term here, because as well as the speed of the lens and its focal length, it's important to consider the lens's minimum focusing distance, i.e. how close up you can be to an object. Take macro lenses that focus very close to objects. It's quite possible to get very smooth bokeh from slow macro lenses, including lenses say as slow as f4. Alternatively, if you're using a faster 50 that has a longer minimum focusing distance, you're not always going to get the narrowest depth of field and not always the smoothest bokeh. There are tools online that will calculate depth of field based on your entries for the focal length and speed of the lens, together with the subject distance. With a longer ultrafast lens wide open, you're hardly going to be able to measure the depth of field. Everything will be out of focus, except for a sliver of an in-focus plane, great for bokeh, but tricky for nailing the focus. This depth of field simulator is a fun tool to play around with. But I'm personally more interested in looking at the relationship between depth of field and minimum focusing differences, as they have a strong impact on closer-up compositions. To demonstrate this, I'll place a ruler on some glitter, so you can see the depth of field on the ruler and also look at the surrounding bokeh. I'll start with an image taken with the biotar I showed you earlier, wide open on a full-frame camera. For all the shots, I'll be focusing on the 10 cm mark of the ruler. The lens produces excellent bokeh to my eyes, but the early versions have a relatively long MFD of 0.9 of a meter, so it's not possible to get up close to the ruler. If you do zoom in, you can see hints of the swirls the biotars are famous for. Long MFDs can of course be overcome using extension tubes, and here's a shot using the biotar with an extension tube. If you're using extension tubes, you'll be narrowing down the frame, and you might think that this negates some of the more interesting bokeh effects, but I think the bokeh here is quite dramatic and well worth photographing. And here's a close-up taken with a genuine macro lens, Nikon's 55 f2.8, less distortion in the ruler and less crazy bokeh. Back to standard lenses, let's take a look at how different lenses with different speeds have different depths of fields and different looks to the surrounding bokeh. The first lens is a 35 f0.95 lens, designed for APS-C cameras. It's the fastest lens I own. No surprise to see a very narrow depth of field across the focal plane, lots of out-of-focus blur in the background and foreground, and reasonably smooth bokeh too. Next, a 55 f1.2 lens full frame. Wide open, it exhibits some chromatic aberrations on the numbers at and around the focus point, which together with ghosting and glare can definitely change the look of wide open close-up bokeh shots. And here are some shots from fast 50 lenses with different speeds, optical designs and minimum focusing distances. The Tessa is probably the most surprising here, a relatively slow lens at f2.8, but it has excellent subject isolation, given its minimum focusing distance of 0.35 meters, one of the shorter MFDs of old 50s. The out-of-focus area's top left, yes, is a hodgepodge of glitter, but the lens hasn't produced a particularly smooth rendering of these shapes and highlights. It's a bit bitty in my view. In terms of minimum focusing distances and bokeh, it's not just fast 50s that can have overly long MFDs like the early biotars. It's also something that impacts telephoto lenses, lenses at 85mm or longer. Take the so-called 135mm bokeh monsters with multiples of aperture blades. Some of these lenses have rather long MFDs that can negate their power closer up. This lens, for example, the Mea Primata, produces lovely soap bubble bokeh. It has 15 blades, but the MFD is as far out as 1.6 meters. Not so good for narrow depth of field images. The conclusion here is that the depth of field does impact how much blur you're going to get, and if you're choosing between, say, a variety of fast 50s and 135 lenses for bokeh-rich shots, it's worth considering each lens's minimum focusing distance, and not just its speed. One other critical point to emphasize about depth of field and bokeh characteristics involves the transitions between into and out of focus, from the in-focus plane to the out-of-focus parts of the image. If you'd like to test the transitions of your lenses, then taking wide-open photos of fences and railings close-up are a good and sometimes fascinating test. You'll be able to find out how some lenses have smooth and natural-looking transitions, while the transitions from other lenses can look very abrupt, with a rather unnatural sliver of focus. This is not just a depth of field thing, it's how the lens is rendering the transitions. I have to say that most classic primes I've used have pretty good transitions, but a few modern lenses, most notably zooms, don't handle transitions so naturally. Personally, I prefer the more natural transitions look. However, there are compositions where you can use in-focus planes to your advantage, such as accentuating this snail trail up a wall. Before I leave transitions and fences, this image is particularly interesting. It was taken with a cut-out arrow shape on the front of a Helios 44-2, acting like a diaphragm. It shows how the arrows change directions before and after the focus plane. There's clearly a lot more going on as light passes through the glass than is apparent in many bokeh shots. The next formal way to measure how different lenses have different bokeh effects is to photograph bright out-of-focus highlights, something I'm going to demonstrate using a wall of coloured fairy lights. Bright points of light, when they're out of focus, produce specular highlights, bokeh balls or bubbles. I'll call them bubbles from now on. And different lenses produce different size and shape bubbles. The size of bubbles depends on a number of factors: the size of the aperture, i.e. the speed of the lens, its focal length, as well as the minimum focus distance. Generally, you'll see bigger bubbles the closer you focus. Given these variables, it's more interesting to look at the different shaped bubbles that different lenses produce, and how these shapes impact bokeh. Lenses typically have curved glass, and a highlight that is completely round at the center of an image frame will become distorted as you move away from the center. The shapes away from the center are often referred to as cat's eyes or ovals, although some lenses produce other shapes, as we'll see. It's actually a three-dimensional distortion, because as the light passes through curved glass, it's rotated or twisted by the curve of the glass. Take the bubbles from a Helios 44-2. If I put a star-shaped cutout on the front of the lens, you can see how the star shape is twisted in a three-dimensional way away from the center. The way a lens's glass distorts light helps to explain some of the bokeh effects different lenses produce. I say some because it's not the only factor, but it is very important. With the Helios lens, you can tell that the shape of the highlights away from the center will encourage a swirly look. So if you take a photo outside in the real world with highlights in the background, catching light through the branches of trees as a classic example, you'll produce a swirly looking image. But other lenses produce different shapes from highlights, and this has a different measurable impact on the look of the bokeh. Here are some examples, including lenses that do and don't swirl. Most of the lenses I've tried with this wall of lights produce broadly symmetrical shapes away from the center, i.e. both sides of the cat's eyes or ovals are similar. Let's start with the bubbles from a triplet lens design. As I've already mentioned, this lens draws clear lines around the edges of the bubbles, an effect that produces the soap bubble bokeh effect that some people value so highly. Now a Tessar lens, a lens where there's no hint of swirl in everyday images. From the wall of lights, yes, the bubbles rotate at the very edges of the frame, but it's not enough to give a swirly look. The rotation is far more widespread from the Helios. Not all lenses produce ovals and cat's eyes that are symmetrical. The Takuma 35 f2 and f2.3 lenses, for instance, produce some of the least symmetrical shapes I've seen, quite significantly squashed on the outer edges. and the resulting bokeh reflects these distortions, creating some unique effects. More subtly, there are lenses where the ovals are a little squashed on the outside. Or a little squashed on the inside. Or finally, this from the Tomioka 55 f1.2, where the bubbles are slightly squashed, and they are also partly impacted by a metal lip on the rear of the lens. It's not surprising, given these shapes, that this lens produces some rather eccentric bokeh wide open. So you can measure and categorize the out-of-focus highlights from different lenses with this type of test, and use the results to tell what a lens's bokeh will look like wherever there are strong sources of light in your compositions. One other useful finding from photographing a wall of lights concerns the optimal focal length for getting the most swirly look from lenses that swirl. With the Helios 40, for instance, you can see how large the bubbles are at the minimum focal distance. The bubbles are really too large to show maximum swirl. Move the focus out a little and the bubbles get smaller, and the swirls are more prevalent and more obvious. Moving slightly away from the subject in focus is precisely the adjustment that works best when you're out in the field and want to produce the best swirly effects from the Helios. There's another bokeh characteristic you can observe with out-of-focus highlights that the wall of coloured lights doesn't show very well at all, but white lights do. This is a small tree of LED lights where every light is white. I photographed the tree with a variety of lenses in a dark room. As you can see, all the lenses have rendered some of the white lights in different tones. It's not all white. The lenses do this wide open and stop down. What's happening here is that the lenses are picking up different levels of brightness from the LED lights. Some lights are shining directly in the lens, some are partially obscured by branches, and with others the angle of the LED bulb itself is pointing away from the lens. If I rotate the tree, you'll see how the lens is picking up different levels of brightness and producing different tones. Out in the field, the differences are not so noticeable, partly because of the variety of colours in and around the highlights. On the subject of bubble colours, you can see some vivid multicoloured flares inside bubbles in very strong light. And sometimes some amazing geometric shapes inside bubbles, caused by reflections from inside the body of the lens. The next bokeh effect you can investigate using bright points of light is the way lenses render out-of-focus highlights when the lenses are stopped down. This, of course, is all about the number and shape of the lens's aperture blades. The number of blades in camera lenses, or lenses we can adapt to use on cameras, range from no blades at all to 20 or more blades. Of course, if you're using a lens wide open, the number of blades makes no difference at all to the bokeh, not even for the so-called bokeh monsters, with 15 or more aperture blades. However, the number and shape of aperture blades does matter as soon as you start stopping down, and they can have a significant impact on the look of out-of-focus highlights. The shape of the blades could be straight or mostly straight but with round corners, or rounded, and the way they look closing down can also differ. Some lenses' aperture blades show a reasonably consistent set of geometric shapes as you stop down, but some can also show notches. And some lenses produce sawtooth shapes at certain stop-down points. The blades don't just impact the shape of the highlight stop-down, they also impact the look of starbursts or sunbursts. This is one of my favourite bokeh images, taken with a lens that has 8 blades. It produces a variety of interesting out-of-focus and optical effects, straight-sided octagons, very clean starbursts, and so on. You could argue that the starbursts are not technically bokeh, and they're not blur, but personally I think they contribute to the overall effects in the out-of-focus areas. This 8-bladed lens, with an even number of blades, produces starbursts with 8 rays or spikes. Lenses with odd number of blades produce double the amount of rays, so this image from a lens with 9 blades has produced 18 rays. I went through my collection to select lenses with different numbers and shapes of blades, and look at their images stopped down, and here are some of the main findings. Firstly, I own some lenses with no aperture blades, such as this mirror lens. The light bounces off a mirror at the back onto a mirror at the front, and then back down the centre of the lens into the camera, and given the shape of these arrangements, it produces distinctive donut highlights. It's a lens designed for long telephoto shots, of course, without donuts, But this particular lens has reasonably close focusing, and when you do focus closer, you can capture plenty of donuts in the right light. It's a good lens to illustrate how busy bokeh can overwhelm your subject in focus. Then there are projector lenses with no aperture blades that you can adapt to digital cameras. These images are from a light's color plan, and it produces nice bokeh bubbles, as well as some of the smoothest bokeh in the right conditions I've seen from any lens I've tried. Next there's the Zenitar ME1, a lens with 2 aperture blades. It's a lens I don't own, but I can recreate the look of the out-of-focus highlights using a square filter on the front of a conventional Zenitar M51.7. The ME1 was probably optimized for stop-down in-focus sharpness, not out-of-focus bokeh, but the effects are interesting. And the images demonstrate how the aperture blades influence the patterns and the textures in out-of-focus areas. They also show that even stop-down, faster lenses can produce a lot of bokeh. With lenses under 10 aperture blades or so, especially with a smaller number of blades, the polygon shapes can be really very noticeable if there are highlights in the bokeh. If you read reviews online about a lens such as the Carl Zeiss Ultron, you can find reviewers praising most aspects of its performance, but lamenting the low number of blades it has. It only has 5 blades. It would be so much better, they say, if the lens had more blades for smoother bokeh rendering of highlights. I tend to agree. I have versions of lenses that started with 10 blades, and then later versions went down to 6 blades, presumably to cut costs, and I prefer the overall bokeh look from the 10-bladed lenses, the rounder highlights stop down a little, rather than the more intrusive geometric shapes. Personally, for lenses that produce strong polygons, I tend to prefer to use the lens wide open to avoid the geometric shapes, but that's my preference. You may have a different view. Not everyone's a fan of the sawtooth look either, such as those produced by the 10 aperture bladed Helios 40, and the very rare Takuma 100 f2 with 8 blades. Lenses that have a lot of blades, say 15 or over, help to keep the edges of the out-of-focus highlights smoother as you stop down a little, rather having the more obvious geometric shapes, although the blades can begin to show as you stop down more. Here's an example with the 15-bladed Pentagon 135. As you can see, the lens retains reasonably smooth round highlights as you stop down, but after a while the impact of the blades starts to show. When you get to 20 blades, with the Tear 11A, you have beautiful smooth bokeh, and even when you stop down to f8, you still have images that look like they may have been taken wide open with other lenses. It's also important to note that lenses with rounded blades do not have to have so many blades to produce rounded highlights, and the modern lenses I use do tend to have more rounded blades to give more rounded out-of-focus highlights. To me, the main takeaway from testing lenses wide open versus stop down involves the trade-off between the sharpness of in-focus areas and how the bokeh looks, together with a consideration of the depth of field. Sometimes it really helps to stop down the lens a little to add extra sharpness to the in-focus areas. That's because not all lenses are particularly sharp wide open, and they can also suffer from other issues such as ghosting, colour fringing and vignetting. So you may need to stop down a few stops to improve the sharpness and deal with other issues. However, when you stop down even just one stop with some lenses, the impact of the blades becomes immediately obvious, especially where there are strong out-of-focus highlights, and the impact is not always very pleasant. Plus, stopping down increases the depth of field, and you can lose some of the attractive blur effects. To sum up this discussion, if you're stopping down, it's a matter of personal taste whether you prefer lenses with a greater number of blades, or at least rounded blades, or conversely, you like the old-fashioned geometric bokeh highlights. For bokeh-rich images, I tend to shoot wide open, for that extra blur and narrower depth of field, and it certainly helps if the lens is a good performer at the maximum aperture, i.e. it's sharp enough on the in-focus areas, and the aberrations are controllable. So far, we've covered the optical and physical design of the lens, but there's one other very significant part of a lens's design that can influence bokeh, and that's the coatings used on the glass. Indeed, taking the lens's optical design, together with the coatings used, goes a long way to explaining why some lenses produce images that people describe as busy, versus lenses that produce bokeh that looks soft and smooth. There are many different types of coating, from lenses with no coatings to the glass, to single coatings, to multiple coatings, to super multi-coatings, to HD coatings, old and new, and so on. Normally coatings appear to be clear, but sometimes there are coloured tints in some lenses, as you can see here, and these tints can tint the resulting image and blur. Then there are lenses that have radioactive elements baked into the glass, designed over 60 years ago to improve the way light passes through the glass, although as radioactive elements age over time, the glass becomes discoloured and can give images a yellow, brown or golden look. I've also tried lenses that don't use conventional glass at all, such as this ultra-achromatic Tachomer, whose elements are made of quartz fluorite rather than glass, designed for scientists to help the transmission of ultraviolet rays and minimize chromatic aberrations. Coatings on conventional glass are primarily designed to improve contrasts and colors and reduce flaring and light leaks. However, these benefits are not always an advantage for bokeh. Some of my favorite bokeh lenses have very limited coatings, and because of this, they tend to wash out images a little, producing lower contrasts and less vivid colors in the out of focus areas. The result is that the out of focus areas in particular have a softer, smoother look, especially where light leaks cover parts of the composition, and some of the details in the blur are less clearly defined. Indeed, the bokeh not only looks smoother, it has more of a painterly, watercolory look, with lighter, less contrasty colours. I should repeat again that this look depends, as always, on the composition and the light. It helps, for instance, to have a low sun, where the sunlight is shining across the front element of the lens. I have many examples of what I think are rather lovely bokeh images from lesser coated lenses in bright light. Sometimes I've deliberately taken the photo without a lens hood as well, and a key to get these kinds of washed out images, especially in the sun, is to try and stress the lens as far as you can without it starting to produce flare artifacts. Unless of course you're deliberately trying to produce flares. The bottom line here is that taking away other variables, the way a lens's coatings handle light and dark contrasts is one of the important factors in understanding why some bokeh looks busy and some bokeh looks smooth. As noted earlier, bokeh isn't all about specular highlights and bubbles. One of the true tests of the quality of a lens's bokeh, in my opinion, involves how it renders out-of-focus blocks of shapes, contrasts and colours, and not just points of light. Through observation, you can look at how different lenses handle the same scene. For example, these three straight-out-of-camera shots, taken within a few seconds of each other. You can compare the blurred coloured cars on the left, and how the lenses have rendered the jumble of branches on the right. The lenses are a smooth bokeh lens, the pan colour, a swirly lens, the Helios, and a less smooth lens, a Tessa. But ironically enough, the differences are not as dramatic as you might envisage. It just goes to show how you need to get the right composition and light for each lens to accentuate each lens's particular effects. To analyse differences systematically across more lenses, I took some shots of this painting. It's a good test because it has interesting blocks of colours, lines and contrasts. This is how the image is rendered by a fast 50 set wide open at its minimum focusing distance, with the gear around 15 feet away from the painting. Here are the results for a variety of old fast 50s, all wide open, and all at their minimum focusing distances. There's no doubting the differences in how lenses render looking across this collection of images. A couple of old lenses are worth singling out for their rather nice blur, and interestingly, they're not the fastest in this collection. I'm not saying that these are my overall best or favourite bokeh lenses. There are other factors to consider than the blurriness of the blur without highlights. However, the lenses are pretty good bokeh lenses. Firstly, the Carl Zeiss Jena Pancolor 50 f1.8, the early radioactive version. For an old 50, it has quite close focusing capabilities at 0.35 meters. The images often do need processing to reduce the yellowing of the glass's radioactive tint, but it's a sharp lens wide open, and the blur it produces is very smooth and well rendered in my opinion. Secondly, the Meyer Optik Görlitz Oriston 50 f1.8. A lens with an MFD of 0.33 meters. There are some big fans of the bokeh and colour rendering of this inexpensive little lens. Here's its take on the busy tree. These two images weren't shot in the same light, but it's quite fun to compare the Oriston's image with a stablemate, the pentagon version of the old Meyer Lilith 35 f3.5, a lens that produces much busier bokeh wide open. These lenses are good examples of why the quality of bokeh is not simply related to the optical design, focal length and speed of the lens in any given scene. It's also about how close the lens can focus, something that explains in part why a sharp old lens, such as the close-focusing Flectigan 35 f2.4, is so highly regarded for its bokeh, especially among crop sensor camera owners using it as a surrogate fast 50. Up to now, we've been looking at the impact that the camera, the lens, the composition and light has on bokeh. There is one more critical factor that can dramatically change the look of bokeh, and that's the use of image processing software. Digital cameras and mobile phones typically apply some sort of processing to the particles of light captured on their sensors. After that, photographers can apply their own processing to a downloaded image, and it's this post-processing I'm going to cover now. Image processing software has evolved considerably since the introduction of digital photography, and AI brings another layer of possibility for manipulating images for their bokeh. We can, for example, use software to accentuate bokeh in an image, or smooth it out. Returning to the photos of the small tree we saw earlier, with the right lens and some processing, you can create much more dramatic images with busy effects and quite a pop. These old Nikon and Minolta Fast 50s deliver some of the more eccentric wide-open bokeh I've seen, but they really need some processing help to accentuate the effects. And take this photo from a venerable old Leitz Elma 50mm f3.5, a lens made in 1937. You can lighten and accentuate the bokeh to make the effects more visible with eye-catching rendering. Or you can do the opposite and completely blur out the background bokeh. Of course, with AI, you can radically change the background, but that's another story. Another way to transform the bokeh in an image is to apply a light or dark vignette. You can produce a high-key image where the out-of-focus areas are highlighted to the point where many of the blurred details disappear. Or you can produce a low-key image where the out-of-focus areas are blacked out. There are numerous other ways to manipulate the bokeh using software. Just one example is to apply motion blur or swirls to an image where the lens itself doesn't swirl. And you can use software to stitch images together to produce photographs with a strong pop and isolation, such as using the Brenner method. The availability and power of software begs the question, do we actually need to use special bokeh lenses to produce beautiful and eccentric bokeh? Can't we simply take one lens and then use software to apply all the desired effects and imperfections we've seen from other specialist lenses? That would save us a lot of money and possibly cure our lens buying addictions. Well, my gut reaction to this is that switching from buying and trying lenses to relying on software would take a lot of fun out of photography. And technically, there are photographic effects that software cannot easily recreate. For instance, software cannot easily recreate the different sizes and shapes of bokeh balls and bubbles from different lenses in a natural way. Yes, software can clone in bubbles into the background, but getting bubbles to sit in and around subjects in focus in a natural way is much more difficult. And even more significantly, a top-quality bokeh lens is a creative tool in its own right, producing artistic images that you may well not have envisaged yourself. Some lenses can really surprise you with how they render scenes almost out of this world. It's certainly not how the human eye sees that scene. Looking at how software creates motion blur or swirls, it's a fun effect, but nothing like the effects produced with genuinely swirly lenses. With these non-swirly Tessa highlights, you see a swirly effect, but you lose the clarity of the twisted cat's eyes away from the center. No matter how sophisticated the software available today, I just don't think it can recreate the beautiful rendering of the best bokeh lenses, or the fascinating surprises lenses can produce. So not all is lost for people like me, and perhaps you, who are happily hell-bent on buying and trying lenses for their bokeh. I started out by wondering whether there is a formula that can help to explain how and why bokeh looks the way it does. And I believe it is possible to break down the constituent parts in the way I've described in this video, based on the type of camera and lens you're using. It's very dependent on the composition and light, and how light passes through the lens's optics, the glass elements and groupings. We saw how different optical designs distort light to produce different looking bokeh, most notably different sizes, shapes, and swirls in out-of-focus highlights. We discussed why a lens's rendering of out-of-focus blur is not simply a matter of the design of the glass elements and groups. It depends on other factors, including the focal length of the lens, its speed and depth of field, as well as the lens's minimum focus distance. And for stop-down shots, it also depends on the number and shape of the aperture blades. We then saw how a lens's coatings impact the look of bokeh, how contrasty and how vividly colourful the bokeh looks, with so-called better coatings not necessarily producing better bokeh. Last but not least, we discussed image processing software and how you can dramatically change the bokeh after an image has been captured and downloaded. Having said all this, we're still missing the final and ultimately the most crucial ingredient of all, the skills of the photographer. These skills are applied in the gear we decide to use, the compositions we choose, the settings we use to take the photo and capture the bokeh in the best light, and how much processing to do to an image once taken. All these decisions make a huge difference to the bokeh in an image. We've seen how lenses need the right scenes and the right light to accentuate their particularly unique brand of bokeh. And to bring this whole discussion of bokeh back to where we started, there are the people who look at our photographs. Do they like the bokeh? Or perhaps they don't like it. At the end of the day, the viewer will be the judge of the bokeh's aesthetic quality. I hope you found this discussion interesting, thought-provoking, and inspiring. If I've missed something major, or you have any observations about the content or the subject in general, please let us know in the comments below. Until the next time, please subscribe if you haven't already done so, and all the best.